All right, so today we're going to look at Module 5, Lesson 13. And I have changed the way that we're learning this just a bit. So our objective is not quite going to match up. The objective for today says that we're going to multiply mixed number factors and relate it to the distributive property and area model. So the key word here that's going to be a little bit tricky for us is this idea of distributive property. And the reason for that is because we have just been multiplying the measurements instead of um, breaking it down and using that partial sums method. So we're going to continue doing that today. The numbers are going to get bigger, so it's going to be a great opportunity for you to practice these skills that we've been learning. Um, But the distributive property, I'll do one problem to kind of show you what it is that we're talking about. But I want you just to continue working on multiplying the length times the width to find the area in a model. So let's go ahead and get started. Scroll past the fluency. Whoops. Okay. So it tells us to find the area of the rectangle that is 1 1/3 inches by 3 3/4 inches. So what they're looking for is for us to use that tiling method, where we would say that this is 1 inch and that this is 1/3 of an inch. Okay, so I've just broken apart that 1 1/3 into the one whole and then the fraction. Then what we really need to think about is that this side here is 3 3/4. So I'm going to switch my ink color here and I'm going to go to green. And the way they're breaking this down is that this big long section here would be 3 holes. So remember when I had my sheets of paper, I would drag over 3 whole sheets of paper, and then down here, this sheet of paper was a 3/4 sheet of paper. All right. So this partial sums method is just pulling apart the whole and the fraction. Okay. So when I do that, this goes back to that multiplication that we used to do at the beginning of the year when we learned how to do multiple digit multiplication. And we would make that box that looked like this. Whoops. And let's just say that I had 20 and 4, and I was multiplying that times 10 and 4. And I would solve each of those boxes and kind of add them together. Do you remember doing that at the beginning of the year? Well, that's all we're really doing here. And so what I do is I take this whole number and I multiply it times 3. Okay. Now, a lot of us have been trying to do this all along, but this is going to kind of give you a visual as to why you cannot just multiply the whole numbers and then tack the fraction on at the end. Let me go ahead and erase this because that was just to activate your schema and get you thinking about what we used to do. So this here, this box would be 3 holes going down this way and 1 going across. So I would have 1 times 3. Now, that's not all I have, whoops, on this section. I have that 1, but I also have this 1/3 that's 3 sections long. So I would have to add that together. Okay, So all I've done is I've taken this 3 here, and I've multiplied this 3 times the 1, and I've multiplied this 3 times the 1/3, okay? Because I've told you all along that you cannot just multiply these whole numbers and then multiply the fractions. You have to multiply the whole number and the fraction by each of these parts. This is called the distributive property. Okay, actually, I'm not even going to write that. I'm going to type that. This is called the distributive property. And if you think about distributing things, when you distribute something, you hand it out. And so I have handed out the 3 to each of this part of the mixed number. So I multiplied this times 3, and then I multiplied this times 3. So the 3 has been distributed both times to both parts of the fraction. Then I would solve that. 1 times 3 is 3. And then this would be 1/3 of 3. That would be 1. So this section, the area is 4. All right, that's the area of that section. Now I've got this little area down here. So I used the 3 before, but guess what? Now I'm going to have to use the 3/4. So I'm going to do the exact same thing. I'm going to take this 1, because this whole section here is 1, and I'm going to multiply that times the 3/4. Okay, so the 3/4, this whole side was 3 3/4. I've already used the 3, now I'm using the 3/4. Now I'm going to distribute the 3/4 with this fraction. And then I have 3/4 times 1/3. All right, so 1 times 3/4 is still 3/4, plus 3 times 1 equals 3. 4 times 3 equals 12. All right. Now I have these unlike denominators, so I'm going to change it. I'm going to change, since 12 is a multiple of 4, I'm going to cross out this 4 and make it a 12. And I multiplied the 4 times 3, so now I'm going to multiply the 3 times 3. So when I do that, I get 9/12 plus 3/12, and that is 12/12, which is 1 whole. So this area down here is 1 whole. So the area of the complete rectangle is 4 plus 1, which would be 5 inches squared. Okay, so that is one way to find the area of this rectangle, by using the distributive property. And that's why we can't just say, oh, well, 1 times 3 is 3, and 1/3 times 3/4 is 3/12, because when I do that, I would get 3 and 1/3, and that is not my answer at all. My answer is 5. So you have to use that distributive property. Of course, the other way that you can solve this is the way that we've been solving it, where we take this mixed number and you change it into an improper fraction. So 1 times 3 equals 3. 3 plus 1 equals 4. And then here I have 3 times 4 is 12, plus 3 equals 15 fourths. All right, now that I've found those, I'm going to come down here a little bit, and I'm going to go ahead and I'm going to change my ink color so that you see that we're doing a different method now. So I have 15 fourths times, what was the other one? 4/3. Now, already I can see that I can cross simplify here. So 4 goes into 4 one time. 4 goes into 4 one time. 3 goes into 3 one time. 3 goes into 15 5 times. Now I can multiply straight across, and I get 5 times 1 equals 5, and 1 times 1 equals 1. So my answer here is 5 inches squared. So there's 2 different ways that you can do this. Obviously, the second way is much more efficient, and that's the way that we have been working these. So that's kind of how I'm going to continue on with these now that I've shown you what the distributive property is and how you can use it to solve the area. So go ahead and you can pause the video here. Make sure that you have all the notes. Rewind if you need to. You should be, this should be kind of old news to you by now, especially this part down here. But this is great practice if you are still struggling. All right, so number 2. It says determine when the distributive property or the multiplication of fractions is more efficient to solve for area. So this time it's asking us to think about, okay, so now you know how to use the distributive property, and now you know how just to turn it into fractions. Which one's going to be more efficient for you to use? I'm going to go ahead and I'm going to start with, let's see, we can do it with the distributive property way. Distributive property. All right, so when I do the distributive property, I'm just going to start here with the 16. Okay? So I'm going to start with the 16 and I'm going to multiply it times the 4. And then I'm going to take the 16, I'm going to multiply it times 1/4. All right, so when I solve for this part, 16 times 4 is 4 times 6 is 24. 4 times 1, so that's 64 plus 16 times 1/4 is 4. Remember, it'd be 16 over 4, which should be 16 divided by 4 is 4. So I get 68. But I'm not done yet because I still haven't done anything with this fraction. So now I'm going to take 1/2 times 4. And I'm going to then take 1/2 times 1/4. And now I'm going to solve this time. 1/2 of 4 is 2. And plus, or I'm sorry, times 1/8 equals 2/8 plus 68. Oops, sorry. 68 and 2/8, which is the same thing as 68. And I can divide the top and the bottom by 2 here. So I can simplify. 2 goes into 2 one time. 2 goes into 8 4 times. Okay, so that is how I solved the area using the distributive property. Now, I'm going to solve it again just by changing it into mixed numbers. So I'm going to erase all that so I can see it really well. All right. Are you ready? Let's see. Let's use blue this time. All right, so 16 times 2. This is where a lot of us are making some silly mistakes. So just make sure that when you're doing this math, you're slowing down. 6 plus 6 is 12. So 32 plus 1 equals 33 over 2. Down here I have 4 times 4 equals 16 plus 1 equals 17/4. All right, so I'm going to multiply these together. 33 over 2. Well, I know that bottom number is going to be 8. That's easy. But now I've got to do 17 times 33. I'm multiplying. So I'm going to take 3. Whoa. That's 21. 3 times 1 is 3, plus 2 is 5. Now I'm going to multiply by 30, so I'm going to add my 0 here. And we get the same answer because it's a 3 again. I'm just going to put that 0 there. So I get 1, 6, 5. So I get 561 over 8. So 8 goes into 561, because remember that fraction symbol means division. 8 times 7 is 56. I subtract 1. So I get a 0, and I get a remainder of 1, which would be 70 and 1/8. So my two answers aren't matching up here. So one of them I have done incorrectly. So because I'm pretty confident in this method, I'm going to come back up and check this. And something tells me that when I tried to do this math in my head up here, that I probably did something incorrect. So let's see here. So I had 16 times 4. Let's go ahead and do that math. 4, 6. Okay, so I got 64. 16 divided by 4, so I got 68. Oh, do you see what I did already? All right, so I had 2 plus 1/8. I wrote that sloppy and it looked like a multiplication. So this here is actually 2 and 1/8. Oh, good thing I tried this both ways, because then I caught my mistake. So even though it's taken me longer, I would have gotten this problem wrong. So now I have 68 plus 2 and 1/8. So that would be 70 and 1/8. So now my answers match. So even if you are doing this and you don't necessarily like to do it this way, but you can, what a great way to go back and check your answers to make sure that you are doing it correctly, because right there I would have missed that. All right, so let's go ahead and let's look at this one. Well, I noticed one thing. I noticed I only have one measurement, but I'm going to notice that this is a square, so they're all going to be the same size. And then this is a meter. All right, so which way do you think is going to be more efficient to solve? Now, you might be thinking the distributive property is not efficient just because it's brand new and you're not used to it yet. So some of you, once we get going, you might really like the distributive method. It just depends. There's a lot of steps. But if you can do it both ways, again, what a great way to double check your work. So let's change this into an improper fraction first. Let's see which way is going to be quicker. 3 times 3 is 9. 9 plus 2 is 11 thirds, which means that this is 11 thirds, which means now I can multiply 11 thirds times 11 thirds, 9. Well, 11 times 10 is 110. And I could add one more 11 to that, and I get 121 over 9. So 9, let's see what the mixed number is going to be. 9 goes into 12. one time. I can make one group if I have 12 blocks, one group of 9, and I would use 9 blocks. Then I would have 31 blocks. I can make 3 groups of 9 with that, and I would use 27, which means that I would have a remainder of 4. So I'm going to write that as a fraction, 4 over 9. I'd have 4 out of the 9 blocks left. All right. So now I'm going to try it with the distributive property. So I'm going to start with this 3 first. I'm going to multiply this 3 times this 3. Plus 3 times 2/3. All right, 3 times 3 is 9. Plus 3 times 2 equals 6. Over 3, that would be 2, so I get 11. Now I have to multiply both of these by 2/3. So I'm going to take 2/3 times 3 plus 2/3 times 2/3. All right, well, I already figured out that this is going to be 2 times 3 equals 6 over 3. So this is going to be 2 plus 2 times 2 equals 4. 3 times 3 equals 9. So I got 11 up here plus the 2 and the 4/9. So 11 plus 2 wholes equals 13 and 4/9. So that time the distributive property was almost more efficient for me. Maybe you like it this way because you're comfortable. And that's up to you. I'm doing it both ways so you can see it both ways. And so that if you can do it both ways and check your work, that is one more step towards becoming a better mathematician. Okay, so now I have number 3. An 8-inch by 10-inch picture is resting on a mat. Okay, so let's go ahead and just draw this picture. This is like a regular old picture frame. 8 by 10. That's the frame. Or that's the picture. Now, the mat has 3/4 of an 3/4 of an inch or 3/4 of an inch around the entire picture. So it says find the area of the mat not covered by a picture. Okay. So let's think of that. So if I have the area of this mat, I know from partitioning it that this is going to be 8, and this is going to be 3/4, and this is going to be 10 and 3/4. So now I've got the dimensions of my mat. So what do you think? Do you think the distributive property, or do you think let's turn it into mixed numbers? Well, let's start with mixed numbers. 10 times 4 is 40 plus 3. 43 over 4. And here I have 8 times 4. That's 32. 32 plus 3 is 35. Fourths. Man, so already I see that this is going to be some serious math because I cannot cross simplify with these. I'm going to have to multiply out 43 times 35. 5 times 3 equals 15. 5 times 4 equals 20. 20 plus 1 equals 21. Now I'm multiplying by 30. 30 times 3 equals 90. 3 times 4 equals 12. So 5, 10, 1 plus 2 is 3, 3 plus 2 is 5, and then another 1. So now I have 1,505 divided by 4. All right, I hope I'm doing this math right because this is a little bit of a humdinger. All right, so I'm going to check my math really quick just to make sure. Okay, so let's take and divide. How many times does 4 go into 1,505? All right, well, if I have one block, I cannot make a group of 4. If I have 15 blocks, whoops, erase that, I can make 3 groups of 4, and I would use 12 blocks. Okay? I would have 3 blocks left over out of those 15. Then I'd look at how many 10s I had, and I had 0, so I brought down my 0. 4 goes into 30 7 times. That means if I had 30 blocks, I could make 7 groups of 4, and I would use 28 blocks. Subtract that, and then bring down my 1s here. 4 goes into 25 6 times. 24. So the area of this entire picture frame is 376 and 1/4 inches squared. Okay, that's everything. What it's wanting to know now is what happens if I take off this area that's 8 by 10, this area that is 80. Because this is the picture. It's 8 by 10. Wait, it is 9. That seems like a lot of inches. So I'm thinking that that cannot be reasonable. So I'm going to come back and I'm going to check my math again. 1043 over 4. 2. All right, so let's see what happens if